level of complexity. Did I put any past exams on the website?
Not that I've seen, but I haven't checked it in a couple days, so.
And you guys, I live in Rockland, and where my zip code is, I'm on wave cable. Friday, the internet went down for my entire community, and it's still down. And so if you email me, I have no idea. I have no way of accessing anything on any computer, any device. So sorry, I'm kind of stuck. Okay, let me come back. So you guys, let me check this out.
Wait a second.
Yes, I'll wait.
Is this 1.7, 1.8, or is it this way?
I think it's 1.9, right?
You're going to embarrass me with a question? I don't know where I'm at.
This is 1.9.
Yeah, exact DE is at 1.9.
Yeah, I think so.
Okay. Just making sure. I gotta make sure these jeepers are allocated properly.
I was going to say something, but I held myself back.
I want to hear it still.
You're going to make me change my vocabulary. So you guys, I need to check for exactness. Actually, I'll say that. I'll tell you later.
If you swear, he'll correct you by saying jeepers.
You know the biggest thing I have to correct?
Yeah.
I was married recently, and my wife has teenage daughters. It took me like 2 years to train them to stop using the word random. Because he used it so incorrectly.
So that's just a random equation right there.
You're grounded. So you guys check for exactness. Well, actually, it's a notation. Can I just think of this above my fingertip as some function called a big M, an xy? And I'll think of this as a function I'll call a big N in terms of x and y. If it's the case that the partial of big M with respect to y and the partial of big N with respect to x, if these two are equal to each other, I've got an exact DE. So let's check. To partially differentiate this with respect to y, oh, a bit of work, isn't it? Look, I've got a product multiplication. So I guess I've got the first times it through the second. Plus the second times it through the first.
Didn't you miss something?
I'm sorry, did you say something?
When you differentiated the natural log of x times y, shouldn't you have an x there too because it's a constant, so you pull it out?
Yeah, you're right, but it's just with a chain rule, I get another factor of x upstairs with the chain rule. Because if I differentiate natural log of x, y with respect to y, don't I get this?
No, I thought you get x over y times natural log of x times y. Because we're treating x as a constant.
True. So how about saying it this way? The derivative of a constant, the derivative of natural log of anything is just 1 over that thing. But the chain rule says it got to multiply by the derivative of what's in the inside with respect to y.
Oh,
I just get a tad bit of cancellation. That's all I suggested. Yeah, just double check. You know I make silly mistakes. But I've lost track where I'm at. Done with the product rule. I need to differentiate the second term, but that's just simply going to give you plus a y. Excuse me, but I meant plus an x. Yikes. All right, you guys, I'm going to stop. Take a break. Take a peek at my big N. Differentiate with respect to x. Oh, actually, I didn't realize it was so short. Piece of cake. So question, yes or no response. Are these equal to each other? No, I don't think they are. Dramatically not, so I don't have an exact DE. But you guys, it could be the case that I could come up with an integrating factor. So can I pull out a nifty piece of scratch paper? Number 1, if it were the case that I were to look at the difference between the partial of n with respect to y and the partial of n with respect to x, and I were to divide by big N as is, if this ends up being a function solely in the variable x, then I proclaim that an appropriate integrating factor will be this. Not only is this an integrating factor, but what it does is it transforms the original DE when I multiply both sides by it into one that's necessarily exact. However, if I were to take a peek at the partial of m with respect to y minus the partial of m with respect to x and divide by the big M, if this ends up being a function solely in the variable y, then necessarily an appropriate integrating factor will be e to the negative of the integral of g of y with respect to y. So I guess the next best thing for me to do is dive in and check to see if any of these conditions truly indeed hold. When I say conditions, I mean this. Does this end up being a function as such, or does this end up being a function as such? So let's give it a shot. You know what, you guys? Maybe I don't want to give it a shot. Can I just take a math deep room to the partial m with respect to y? If I were to clean that up, what do I actually end up getting? Is that a 2x and a 3x? Is it 3x plus 2x? I said 2x times that natural log. And therefore, when I take a peek at this mess, don't I get this? You guys, am I doing okay? However, can we see what happens if I divide out by, what do you think the appropriate choice is?
M, let's go for it.
And if I divide by m, does that give me an xy? Plus 2xy? Natural log of a product. Oh shoot, you guys, this is a math D question. What does it simplify to? 1 over y. Which, by the way, is a function solely in terms of y. So I guess that second condition down there's when you and I, or shall I say, when I was in class yesterday, I think somebody pointed out, when I came over here, I must have forgotten to write a term or something like that. I can't remember the details.
Yeah, that's what it was.
So my apologies. And, let's check it out. The integrating factor will be an integrating factor in terms of the variable y, and it's going to be this. Or shall I say this? Or shall I say this?
So why are you referring to it as g of y again?
Because it is a function solely in terms of y.
Okay.
As opposed to Brad, these functions in terms of two variables.
Okay. So that's all you're saying is that it's just a function in terms of y.
Or shall we say a function solely in terms of variables.
Okay.
So everybody, multiplying both sides of the original DE by this integrating factor, check out what we get. Actually, I guess on the left-hand side, I'm just going to cancel a factor of y here and there, and it's really far away from me. Is that a 2x natural log of product? Is that a plus just an x? And then I guess that gives me a plus x squared over y dy.
You have a line between your x and your line.
Do I really?
Yeah.
Oh, but I'm multiplying both sides by the integrating
okay,
factor.
sorry.
So I got rid of it. And everybody, if you guys don't mind, I am not going to check exactness. It's guaranteed to work. Having said that, let's solve this DE. I want the solution of the form. Phi some function in xy is simply equal to a constant. Where it certainly is the case, knowing what you and I know about total differentials, and I apologize for those of you who have not taken Math 32, but hopefully my discussion last night helped at least a little bit. I think it's got to be the case that with a solution, if you were to take a partial of it with respect to x, you get your function m, which is this mess. Also, with a solution, not that I have it yet, but if I were to differentiate it partially with respect to y, I think I'm left with this dn function. And you guys, I'm just gonna select one of these two phi's of x's or y's to undo the partial differentiation process to come up with my solution phi. It doesn't matter which one you choose, but you gotta confess, I make silly arithmetic errors. It's probably gonna be easier to choose the second one. So if you guys don't mind with the second line, if I were to undo the partial differentiation process, wouldn't that tell me that phi will simply be, take a peek at the right-hand side, undoing the partial respect to y, wouldn't that give you your coefficient times the natural log of y? Oh, did I mess up? I forgot my constant integration, darn it.
Would it be absolute values?
Oh, you're right. But I don't have to.
Okay.
Because I think the input right here is a product of x and y, and if x is strictly positive, that means y's got to be strictly positive because the domain of the natural log is all real numbers strictly positive. I think I'm safe. Number two, I think I made a mistake. Where is it? On the very last line, there's a mistake. Chris? Perfectly put. Chris is saying this. If I go backwards, does the constant go to 0? Yeah, it does. It does. But I think c could be bigger than that. I think c could be as big as a function solely in the variable x, so that when I differentiate, it still vanishes. Do you guys see my point? That being the case, let me go ahead and go backwards. From this line, let's see what happens if I partially differentiate with respect to x. I think I'm merely left with a 2x natural log of y plus h prime of x. However, I don't know if you guys are catching this, but on the inboard, take a peek at what I have. I've got two versions of the partial of phi with respect to x. Here's one version. Here's the second version. But if they're both the partial of phi with respect to x, they've got to be the same. So, in equating my phi's partials in terms of x, I think that gives me the following.
So,
Yes.
when you went from that step to the one above it, all you did was differentiated
With respect to
to
variable
x? Okay.
In other words, I'm treating y as a constant.
Okay,
in
I see,
respect
I see.
to x. And you guys
Okay.
equating these partials with respect to x, it's going to give me this. Uh-oh. Is there a problem these inputs aren't the same? I said, uh-oh. Is there a problem because these inputs aren't the same? I can say that 3 times. Come on, you math experts.
You can split it up, so
I can
it's
split it
it's
up.
the natural log of
Because I think
x
over here I
plus
got
the natural
2x
log of
natural
y.
log of x plus 2x natural log of y plus x being equal to all this stuff. And you know what? When I subtract this piece from both sides, I see that h prime of x is merely my 2x natural log of x plus my x. Oh shoot, that's looking really nice because this is a function solely in terms of x, and so is that. I guess I can now undo the differentiation process. Actually, you know what? You guys, I can't do it. I ran out of room. I don't want to be a graffiti artist. Can I jump over there? That being the case, I need to undo the differentiation process yet again. So, anti-differentiating. Oh my goodness. Okay, I can't do this.
2x.
Say it one more time, I'm sorry. Equals my h prime. So I guess my h of x is simply going to be the values in the center point. Ouch, how do I deal with that? Clearly integration by parts. I think here all I'm going to do is allow you to be a, is it 2x? Yeah, I choose natural log of x so I can get rid of the transcendental function through the differentiation process. I think my dv, however, is going to be everything else, which is my 2x. think paying the consequence of my actions, here's a relationship between du and dx. And I think clearly my v is going to be nothing more than a single x squared. That being the case, I think my h of x is merely going to be, shoot, is that the product of my u and my v? Minus the integral of my v du, ah, shoot, that's just a piece of cake. Oh, I forgot this one. I guess I better add the antiderivative of x, but that's just going to be one of these. Or shall I say, h of x is merely an x squared natural log of x. Yes, I'm so
Where
sorry.
does your constant integration go?
I don't know. I just kind of give up. Because, and there's nothing wrong with putting it in. It's just in the end, I remember my solutions are the form phi equals some constant. And so I just be subtracting from both sides. Well, put it in if you like. There's nothing wrong with that. And you know what? I still don't think I've answered the question. You guys look at what's below the doubly blue underlined statement. What's right about below the blue doubly underlined statement is my phi function. And I think my phi function, if you look over there carefully, is nothing more than x squared. Natural log of y plus my h of x, which I just found to be x squared. Natural log of x. And so I think that's my phi, and if I set it equal to constant, there's my solution. Actually, I can do better than this, can't I? This is just an x squared. Natural log of a product. You guys, I guess in this example, it wouldn't be that bad to solve for y in terms of x. I just give up. It was good for me. I just stated my solution implicitly for y in terms of x. What do you think? I'm sorry, Jason. It's time to tap me. It was boring.
Can we do another one?
What's that?
Can we do another example?
Don't know if I've got an example that extensive. That was a good example.
Okay.
Can I try to do this
It's
in my
just a
head?
lot to
See if
take
it's too
in.
easy?
Oh my god.
Yeah, it's too easy. Oh, this is better. This might be better. What? I'm just not trying not to waste your time.
It's more of you're doing this in your head.
Well, it's not that bad.
There's always this expectations about something the same.
Well, I was being honest. I really do think I grabbed this from the past exam. Everybody, it is time to do the same thing I did last time, check for exactness. And to check for exactness, I'm going to compute the partial in respect to y, but that's clearly,
So,
just zero.
if this question is on an exam, it took you 18 minutes to do this question?
I know, but that's because I'm explaining my way through it. If I actually sit down and actually answer the question, it's only going to take 5 minutes.
Okay,
Well, for you.
for you.
No, for you too. I mean, there's nothing that complex in here. If you know the steps, you know the procedure. And I maintain that was it. You know what? I stole that from the Math 32 exam. That's where I got that example.
30.
And I think the partial n with respect to x is equal to a piece of cake is 3. So, what do I do next to solve this exact DE? Good. In other words, nothing, because I think it's not exact. I checked for exactness, and it failed. So to try to force exactness, if I can, I'm not saying I always can. Typically, I won't be able to do this. But if I'm fortunate enough to take a peek at these expressions here, and I get these functions in those particular single variables, then I'll be able to generate an integrating factor. So let's check. I think the partial m with respect to y minus the partial m with respect to x ends up being, is that a negative 3? Over something. But you guys, let's be selective. If I divide by n, That won't end up being a function of a single variable. But if I divide by m, which is just 1, that's just simply -3, and I could treat that as a function in terms of the variable y. I could. It's just a constant function. And so I think looking at the second criteria down here, sorry if this duplicated what my first example, I think I get a function solely in terms of y. And so I think my integrating factor in terms of the variable y is merely going to be e to the negative of -3 with respect to y, or shall we say it's just e to the positive 3y. And I want n integrating factor. I'm using an indefinite article, so just one will do. So if you don't mind, I'll choose my constant integration to be 0. Now in multiplying, did you save it?
I saved it.
Okay, good. Maybe I should move my desk closer to you. Multiplying both sides of the original non-exact dE by this integrating factor, I think it transforms to this. E to the 3y dx. Is it a plus, oh jeepers, is that a 3x e to the 3y minus e to the y?
It's messing with the board over here. Sorry.
No tricks, I'm just stalling for you to catch up because you're so quiet. Yes, there's a
I am a little confused here.
Where are you
Right at the beginning.
Okay.
So your my and your nx,
Yes.
I thought those were derivatives of with respect to y or derivatives with respect to x.
Yes.
Okay.
But this is my function.
Okay.
Everything in front is a 1.
Okay. And so you force those to be equal to one another.
No.
Is what you've done? No.
I checked to see if they're equal to each other, and they weren't.
Yeah.
Now I'm just panicking. If it turns out this expression is a function solely x, or if this piece here turns out to be a function solely y, if that's one of those the case, I can generate an integrating factor.
Okay.
And one was the case. The second criteria was being met. So I maintain that this will be an integrating factor, meaning when I multiply the original dE by on both sides, it'll bring this dE, transform it into one that is indeed exact.
Why is it equal to 0 there, and not equal to anything?
Because I'm being too sloppy. Sorry. You know, my dE's, if I'm going to check for exactness, really need to be in the form m dx plus n dy equals 0. That's the form I want. And if it's not, forced to do that. So far, so good. If it is, well, let's get to work at finding our solution. Our solution will be able to form some function phi in terms of two variables being equal to a constant. That being the case, I maintain that if I were to take that solution, not that I have it, and partially differentiate with respect to x or with respect to y, I'm simply going to get my new m and my new n respectively. Well, here's my new m. Here's my new n. So if above I undo the partial differentiation process with respect to the variable x, aren't I just simply going to end up with this? You okay with that? No, there's something missing. Plus h of what? Well, I think it'll be h of y, won't it? So when I go backwards and differentiate, this will go to 0 again. However, now coming downwards and partially differentiating with respect to the other variable, by the way, this is my phi, jeepers. Now partially differentiating that with respect to the other variable, I think I generate the following. Instead of 3x e to the 3y plus h comma y. Oh, but you guys, yet again, check out what the heck is really going on. Look at what's above my squiggly red line. And take a peek at what I have doubly underlined in blue. Those are two different versions of the partial of phi with respect to the variable y. They've got to be equal to each other. And so I maintain that my 3x e to the 3y minus e to the y has to be equal to my 3x e to the 3y. Ooh, look at that, they're the same. Plus h prime of y. This is going to allow me to solve for h prime of y. I said y. I think this implies h prime of y. I can't write my y's. Is nothing more than e to the negative y. I guess it's negative e to the y. So that implies h of y is equal to, well, the same thing. Yes, I can add constant integration at this point. I just don't think it's going to make a difference. Michael?
So when you're solving a differential equation and it's exact, once you get to the part where you found that it's exact, where you force it to be exact, you take the partial phi with respect to some variable and finagle your way to the other variable.
Absolutely, absolutely true. And notice in this example, I think, I did something different than my last example. I think on my last example, I undid the partial differential with respect to x only because it was easier. So I just undo the partial with respect to whatever one makes my life easier so I don't have to make any silly mistakes. By the way, you know what? I think I'm ready to state my solutions. How about a big box? If my solutions are the form phi being a constant, oh, and phi's right here, then I will take what's above my fingertips. That is to say, my x, e to the 3y, plus my h and y, which I just found to be negative e to the y, and set it equal to a constant. There's my solution. Yes, sir?
So when we see this, like for example, in the exam, questions of this type, will they be given to us in that separated form, or might it be given like with the dx on the other side and then divided from it?
Oh, I've done that in the past where it's dy dx.
Okay, and then we have to manipulate it.
And see if you, and if it's really close to, if it's close to being exact, then you want to try for an integrating factor. Perhaps you can look at it this way. This seems like the most complex technique so far. So maybe give up and just glance and see if you can apply the other techniques first.
What do you mean by close to an exact? Like, what would it?
Well, you know, if you look at these two partials when I was trying to check for exactness, one was a constant, the other was a constant.
Yeah.
That's so darn close.
Like one was like an x, and then the other one was like a y. That'd be close still.
In that case, I'd probably look at my original m's and n's and see if they involve both x's and y's that simplistically. I have to confess, my first example wasn't that nice, was it? I think it was a bit more tricky, I think. Anybody else?
Have you written the test yet?
Yes.
Is it scary?
So this is a little on the easy side.
Okay, good.
So the first step on the little board, so did you use, I guess, second interval, like set y? And basically you're dividing by
M.
n.
Yes, sir. Check this. Michael, is it Michael? Michael, check this out. That really is understood to be 1.
Okay.
So I did divide by the m.
And then the -3 comes from,
The difference between these two, the difference between this one and this one.
okay.
So this beast minus that beast.
So, can you just explain steps I and or 1 and 2 there? Really fast. It's just you got the m of y minus n of x over n equals f of x. Why does it equal f of x?
It doesn't.
Okay.
This is a conditional statement.
Okay.
I'm saying if this is true, then my integrating factor is equal to this.
And so, what's your f of x in this situation?
Whatever this turns out to be, as long as this functions solely in x.
Okay.
Look at this one. As long as this is a function solely in y, I can generate an integrating factor, but look, there is my g of y. This is a function solely in terms of the variable y.
Okay, so all that means is that it's solely in terms of x, solely in terms of y.
True, and now maybe you're going to jump on my case saying, well, I don't see any y's over there. That's fine, but at least I can think of this as a function y as a constant function.
So if you plug those values in there and you have an x, y in there, then it just doesn't work.
True. If you end up generating what this beast is, and it ends up being a function of both x and y, then certainly it will not yield an integrating factor.
So
So check this one, see if you end up with something meaningful, but if this too ends up being a function of both x and y, shoot, even there I can't generate an integrating factor, it implies I gotta give up on this technique.
And so, in a situation like that, would you ever try and like maybe massage the equation or figure out a way to rewrite the equation so that it doesn't end up like that? Or is that even possible?
No, I wouldn't, I'd just try a different technique.
Okay.
Well, maybe you guys, I can get through just 2 more examples today.
Sure.
2 more examples and I'll stop talking.
You going to the math center today? You're studying?
No, I haven't opened up today. Why?
I'm just trying to see who's going to be in there studying. So I do better in a group.
So you guys ready for something completely new?
I'll post it as soon as I get home.
So why do you think this is something completely new? Yeah, it's a second order DE. Notice something interesting about it. It involves no dependent variable. There's no y. Now, I am not going to stand here today in just 15 minutes and somehow try to train you guys on how to solve second order DEs. I'm only going to do it with these special case scenarios. If I'm missing a dependent variable or if I'm missing an independent variable. Here, since I'm missing a dependent variable, here's my tactic. It's a common technique in this course this semester. It's just yet another reduction technique. I'm going to, by brute force, make a substitution to reduce the second order DE to a first order DE. Then you got, oh shoot, all those techniques we've already learned how to use to solve it. So let's give it a shot. I am going to allow u to be equal to dy dx. If I do, I think du dx is going to be the second derivative for y with respect to x. And in committing to the substitution, I think I get to rewrite that dE. I think it transforms into a du dx being equal to an x minus, well, y prime is just u. Oh shoot, you guys, look at that. That ends up being a first order DE. Don't we use all the DE? I would. I think it's first order linear. I use an integrating factor. Rewriting. Does that just become a du dx? Being equal to, I misspoke, sorry. I meant plus a u being equal to x. Where my integrating factor is simply going to be a you ready for this?
E to the x.
E to the x. And in multiplying both sides, I sure hope you're sick of me saying this. And in multiplying both sides by the integrating factor, which you would have on the left-hand side if I wrote it all out, would be the result of differentiating with respect to x my new dependent variable u with my integrating factor. Oh, but don't forget, I really am multiplying both sides of my d by the integrating factor. And in undoing the differentiation process, that gives me u e to the x is equal to, well, my technique is going to apply integration by parts. Clearly, that's an x e to the x. Is that a minus e to the x? Oh, shoot, it's not. I really made a mistake again. Plus my c becomes important. Or shall I say, u is equal to x minus 1 plus c times e to the negative x. Are you happy? I asked her, are you happy?
No.
No, I'm not happy either. I'm not happy because I think that doesn't really solve for y in terms of x. Something else. Do you think I call C1? There might be some more constants popping up. So back substituting, replacing u with its alternative name. Since the entire right-hand side is solely in terms of x, do you guys mind if I just give up on math 33? Can I just apply math 30? It's anti-differentiate term by term. I think y is a function of x is simply a 1/2 x squared minus x plus, well, I misspoke, plus c2 e to the negative x plus c3. It's not that bad, is it?
Well, shouldn't you be stating what your constants are equal to?
If you insist.
Well, unless you don't require us to, but
Come on, you guys, I'm giving you a moment to attack me. Anything on the board is unclear.
it looks pretty clear.
I was hoping so.
Is it possible for us to have to use two separate techniques if you give us a second order?
So if we're going from dx to y, you just integrate?
Yeah, it might, you don't like the way I'm saying that, Michael? Do this, separate variables. Get exactly the same thing. I was just being lazy trying to beat that along. Well, everybody, our last example for the day, and then you don't have to listen to me anymore. So last example. I'll be selective. This one I cannot do in my head, but it looks nasty. Well, I think this is quite different than my last example because if you take a glance at it, you see no x's. This is a second order differential equation with no independent variable. Now I'm going to start the process off the same way. I'm simply going to dive in and allow you to be equal to dy dx.
So
Yes.
why wouldn't you maybe simplify by combining like terms first?
Oh, because I didn't see that I could. Where?
Well, you've got a y prime squared, and then you've got a y prime cubed. Oh, well, actually, it'd probably just make things worse if you tried to.
Not that it would make a difference in the long run.
Yeah.
There's nothing wrong with manipulating the original differential equation,
Yeah.
combining, or even separated terms. That's not going to affect your ability to solve it.
Okay.
And paying the consequence of my actions, I think du dx is equal to my second derivative for y with respect to x. And I am very unhappy. Because I've already got y's, now I got u's, now I get du dx. It's a different variable than y. I can't use it. So I'm going to apply the chain rule on the left-hand side. Applying the chain rule on the left-hand side, I will think of du dx as du dy instead. But the chain rule says multiply by dy dx. Shoot, I still can't. Darn it. That's in terms of x. I can't do this. I got an idea. Another name for dy dx is just u.
Wait.
I'll wait.
So why did you
How did you?
think by with respect to y?
I can't avoid it because I already had a dy dx. And so I was stuck with that. But now that dx down below, or the x down below, gets absorbed into the u. Now committing to these two lines for my substitutions, let's you and I dive in and see if we can't rewrite the original differential equation. I guess my y double prime over there, the very first term, has this as alternative name.
I'm a little confused
On
here.
which one?
On step 3.
So